Welcome to Mount Guide International Remote Learning Program. Myself Shemi, your chemistry teacher with the topic Chemical Reactions and Equations. Part 3. In Part 1 and Part 2 we have discussed combination and decomposition reaction. Here we are going to see displacement reaction and rest of the content. So displacement reaction, the definition given here. When an element displaces another element from its compound, displacement reaction occurs. Otherwise, we can say that the most reactive metal will displace the least from its salt solution. We have a reactivity series, order of metals. So based on the order of metals, based on the reactivity of the metals, the displacement reaction occurs. Here we have metals like iron, copper, zinc. So zinc is more reactive, then comes iron, and then comes copper. So let us see the first example, copper sulfate plus iron. If a metal compound, copper sulfate, reacting with iron. As I said, iron is reactive than copper, powerful than copper. So iron will go and displace copper from its position, and iron will occupy copper's place. That is what is happening. So iron sulfate is formed, copper is removed and left as a separate metal. That is what displacement reaction. Similarly, we have second and third one, similar type of reaction. Copper sulfate plus zinc gives zinc sulfate plus copper. Lead plus copper chloride gives lead chloride plus copper. So all these displacement reactions are easy to write. Only we have to move a metal from one place to other place, other one out. So let us see with a video the same thing. We have taken 2 test tubes and 3 iron nails cleansed with sandpaper, and the test tubes are clamped over. We are labeling it as A and B, and both the test tubes has got a blue color solution, that is copper sulfate. We are dipping iron nail into a copper sulfate solution and finding out the changes. So if we keep it aside for some time, we can observe the change. See the iron nail, the earlier it is silvery gray in color, it is cleansed properly. After the reaction, see the change. The silvery grey color iron nail have become reddish brown, and the blue color copper sulfate solution have turned to green color solution. It is because of the chemical formation iron sulfate, the first reaction what we have discussed. So this is what we are calling it as displacement reaction. Iron have become copper, reddish brown copper. Next we will discuss the fourth type of chemical reaction, double displacement reaction. The first one, it is single displacement, only an ion moves and it removes copper from its metal compound. That's what. But here both the ions will get interchanged. See the first reaction, Na2SO4 BaCl2. So both here in the first reactant Na will move and the second reactant Ba also will be moving. So both the ions will get interchanged. As both the ions are getting interchanged, we are calling this reaction as double displacement reaction. And double displacement reaction usually are known as precipitation reaction, because precipitate is nothing but a fine solid substance. For example, if you mix paste, our toothpaste in water, how it looks, a thick solution, right? Similarly, if you mix these two chemicals like sodium sulfate and barium chloride, you will get a white precipitate because of the formation of barium sulfate. So that is why double displacement reaction usually we are calling it as precipitation reaction. And the second one, we have lead nitrate plus potassium iodide. Both ions got interchanged. The product obtained is lead iodide and potassium nitrate. So here both the solutions are colorless, but after you mix you will get a beautiful yellow precipitate. So precipitate is obtained here also. Let us see the same with the example of a video. Here we have taken all the chemical apparatus, conical flask, beaker, test tubes, and we are taking barium chloride solution in one of the test tube and pouring into conical flask, and sodium sulfate solution in other test tube, that is also being poured in the conical flask. See, you can see a white paste like solution obtained down. This is known as precipitation, and it is because of the formation of barium sulfate. Now let us move to the next, fifth one, oxidation reduction reaction. So this is the fifth type of chemical reaction, oxidation. Oxidation is nothing but addition of oxygen or gain of oxygen. So if an element, if it is getting added with oxygen, we'll call it as oxidized, and the reaction oxidation reaction. For example, copper is added with oxygen, that means copper is oxidized and the product obtained is copper oxide. So the reaction is known as oxidation reaction, and the definition is like oxidation is the gain of oxygen or loss of hydrogen. Either hydrogen has to be lost or it has to gain oxygen, but we are not going to see the examples of hydrogen here, only we'll discuss with oxygen. Second example, zinc plus oxygen gives zinc oxide. Then the next one is reduction, just opposite of oxidation. Oxidation is addition of oxygen, reduction is loss of oxygen. See here, copper oxide is reacting with hydrogen. After the reaction, copper has lost its oxygen. Copper oxide have become copper. That is what, if oxygen is being lost, then we are calling it as reduction. Entirely opposite of oxidation. Oxidation is the gain of oxygen, reduction is the loss of oxygen. Then next one, it is redox. So it's clear, redox means reduction and oxidation. If both the reactions, if it is taking place in a single chemical equation, we are calling it as redox reaction. For example, manganese oxide, if it is reacting with hydrochloric acid, the product obtained is manganese chloride plus water plus chlorine. See, manganese oxide, the product, it has become manganese chloride. So this oxygen is removed, so it is reduced. Likewise, HCl have become water. So hydrogen is added with water. So here reduction. So oxidation, reduction, if both the type of reaction, if it is happening in a single chemical equation, we are calling it as redox reaction. So that is all about oxidation reduction. Usually they'll give equation during the board examination, and they'll ask you to identify which is oxidized, which is added with oxygen, which is reduced, which has lost its oxygen. Only that identification you have to go for oxidation and reduction. The next one is corrosion and rancidity. This is like an example of oxidation reaction. See, if a metal is being added with oxygen, and if the metal surface is being damaged or degraded, then we are calling the process as corrosion. Similarly, if food materials, especially rich in oil, fat, if it is being added with oxygen or oxidized, we are calling it as rancidity. In case of metal, the process is corrosion. In case of food materials, the process is rancid or decaying. Simple, it is decaying of food materials. So here, if you want to prevent corrosion, you all know that what we will do. We'll go for painting, we'll go for oiling, we'll go for greasing. Otherwise, we have galvanization, means coating a metal with zinc, sacrificial anode, anodizing. Many processes are there, but simple processes like oiling, greasing, painting. But in case of food materials, to prevent oxygen contact, what we'll do? We'll keep in airtight containers, or we'll go for refrigeration, that is keeping in the fridge. Otherwise, the food materials, the packet food material, the snacks, the crispy snacks what we are getting from the shops, how the crispiness remains for longer days? Because inside the packet there is no oxygen. Oxidation is not happening. because before they pack they are flushing nitrogen gas inside the packet, and all the oxidants are removed. So the packet is free of oxygen, so no oxidation. Food materials remains crispy without decaying, no rancidity there. So that is what corrosion and rancidity. Hope children you might have got the content. Read the textbook, go through the slides again, and then try to ask questions and answer the task. A simple task is given here, plus do all the homeworks and upload the activity as per your knowledge. Thank you.